What we're going to look at here is the concept of free energy, and remembering that this energy is the energy available to do work. And what we want to look at is the differences in free energy in a reaction. And the change, or the difference, is going to be a little triangle known as delta. Okay, so that's going to be the change in the free energy. And what we have to remember is that that delta is going to equal the free energy of the products minus the free energy of the reactants. Okay, and this is important to remember when we look at whether this delta is going to be a positive or a negative number. So products minus reactants. Looking at the graph, remembering time, that reactants are always going to be going to products. So timeline, you start with reactants and you end with products. So we're going to have two different possibilities here. Let's look at the first one. In that the free energy, okay, is going to be lower for the reactants compared to the products. And the graph will look something like this. Okay? If we look at the difference between the free energies, we're going to see that this is the area we're concerned with here. This is the delta. And remembering that the products minus the reactants, here the products value is greater than the reactants. So this is going to be a positive value. Okay? And a positive delta G is known as an endergonic reaction, and it requires an input of free energy because the products have more free energy than the reactants. Let's look at the next situation. Again, reactants go to products. However, in this case, the reactants are going to have higher free energy than the products, and the curve will look something like this. Remembering again that the difference in free energy is going to be the delta G. And in this case, the products have a lower free energy than the reactants. So product minus reactants is going to be negative. And this is an exergonic reaction. And because the reactants have a higher free energy, this means that free energy will be released. Now let's look at the relationship between exergonic and endergonic reactions. Remembering that exergonic reactions release free energy and endergonic reactions require free energy. So what we can do now is we can couple these two types of reactions. Exergonic reactions are going to release the free energy, and that free energy then can be used by the endergonic reactions. And this coupling of the energy between the exergonic and the endergonic is known as energy coupling. And we're going to see this throughout physiological mechanisms, and we will be discussing this when we look in more detail at cellular respiration. So in summary, let's remember that exergonic reactions are downhill reactions, a negative delta G, and they release free energy. Okay, these are the exergonic reactions. And these are going to be coupled with uphill reactions with a positive delta G, and these require free energy. So you have the energy coupling between an exergonic reaction and an endergonic reaction.